Hey guys, and welcome back to my YouTube channel. Today we're doing Target 9B notes. You guys have been doing great with this e-learning stuff so far, so let's keep up the hard work. So today, there we go, everything was frozen for a second. Alright, so today we're doing 9B notes. So it says write and graph exponential functions, right? So we're moving into exponential functions. So 9A was doing exponential functions. You guys just didn't really know it. So exponential functions, right? That's when you are multiplying or dividing each time. My handwriting is going to be janky. We're just going to have to roll with it. So exponential functions are when you're multiplying or dividing each time. So that's going to change what your graph looks like. So it says, which of the following graphs below represents exponential growth or decay? So we have exponential growth here or decay. So those are two different things. So exponential growth, your graph is going to increase. So it's going to kind of increase slowly at first and then increase really quickly. Decay is when it starts decreasing really quick and kind of evens out. So this is exponential growth or decay, right? If we think back, we've done linear, right? We've done lines where it just goes straight up or it comes straight down, right? But now we're kind of looking at ones where it curves a little bit. So we want to pick out of these ones which ones are growth or decay. So if we look at A, right, this one's growth, right, because your line is starting and then it goes up, growth, right? Let's look at B. B is not. This one is linear. This one's a line. It's not exponential. C. Yep, this one is, right? This one is decay because your line is going down. If we look at D, nope, this one is linear, right? It's just a straight line. There's no curve to it. E, this one is, right? Because if you look, your graph is coming down. It starts quick, but then kind of evens out a little bit. So this one is decay. And then if we look at F, this one also is, right, because you have a bit of a curve. So it starts out going down really quickly and then it kind of evens out. So this one is decay as well, right? So that's kind of what up here I touched a little bit on exponential growth or decay. So we're going to look at the difference between the two of them. So I've already kind of drawn the graph. So exponential growth, your numbers go up. Whereas exponential decay, it comes down. So exponential growth comes when you multiply. So your number that you're multiplying is bigger than 1. Whereas for decay, this is when you divide. So your number is going to be less than 1, right? But not negative. We want to make that note because negatives don't work for these. So exponential growth and exponential decay, right? The number that you're doing is always, whoa, oh God, having technical difficulties as always, right? So your number is always positive, right? That's a key thing. Your number is always positive. So for exponential growth and decay, right? So our general formula that we're going to be using now is f of x equals a times b to the x. So if we were looking at our other numbers, so this is kind of like your a1 and then this b is what your r was when we were doing the formulas from before, right? So a is going to be your starting number, and then instead of having r inside the parentheses, we're using b because now we are looking, right? This means we have a function. right? So we're not just looking at a list of numbers, right? We're going to be looking at a table, we're going to be looking at graphs. So with this one, we need a function instead of just a set of numbers. So the A is your starting number, right? And then the B is kind of what you're changing by each time. So it's saying find 3 ordered pairs that would represent points on the graph of each given function. So we've got f of x equals 2 times 5 to the power of x. So we're going to just make a table for this one to find our ordered pairs, right? So we're going to have our x numbers and our y numbers, right? Y is the same thing as f of x. We're probably going to need a bit of room to figure these out. So I'm just going to pick 3 numbers. So I'm going to say 0 is one of my x's, 1 is one of my x's, and 2. Okay? So all we're doing is taking, right, the number that we chose for x and plugging it into our equation for the x. So first our x is 0. So we're doing 2 times 5 to the 0 power. And you always do the number with the exponent first, right? If you think of your order of operations, right? Please excuse my dear Aunt Sally. Exponents comes before multiplication. So you do exponents and then multiply. So you do the exponents first. 5 to the 0 power, right? If you go to your calculator, we're doing 5 to, right? You just click the little caret to do the exponent. 5 to the 0 power. Oh, that's 1. Great. So we can go in and say we're doing now 2 times 1, which is just 2. All right, then we move. So now we're doing 2 times 5, right? We're just plugging in the number for x in where the exponent was in our other one, right? So our exponent was up there, the x. So the 2 and the 5 stay the same every time. You're just replacing that exponent with a different number. So now we're doing 2 times, and then we go to our calculator to do, okay, what's 5 to the first power? 5. Cool. So 2 times 5, which is 10. And then we're doing 2 times 5 to the second power now. So 2 times, right, 5 to the second power. So 5 to the power of 2 is 25. So to get that, right, that's the same thing as doing 5 times itself. So 5 times 5, which is 25, right? So that's kind of what exponents are. You're doing that number times itself, however many times of the exponent. So we're doing 2 times 25, which is 50. So it says find 3 ordered pairs. So our ordered pairs we're going to choose is 0, 2. That was the first one. Then our next one was 1, 10. And then our next one was 2, 50. Right? So as you can see, right, our numbers are growing by multiplying by 5 each time, right? Which is what number is inside here. But we started at 2, so 2 was the first number, and then we multiply by 5 each time to get the other numbers, right? So very similar to how it was before, just this time, instead of having that whole n-1 business, we just have an x, so you're just plugging in the number for x each time. For the interest of time, I'm not going to do B. If you'd like to do B, you may do B, but I want to make sure, because my video only lets me record 15 minutes at a time, that we get through at least one of our graph ones, okay? So number 4 for the graph, right? It says fill in the table with the correct values, and we're going to graph it. So same thing as before, right? We're using kind of the same table that we were doing before. So we've got 5 different numbers to plug in for the x. So we're taking all of these x values, so -2, -1, 0, 1, and 2, and we're going to plug them in for, I made that way too big. We're going to plug them in for x on your exponent, right? So the only number that's changing each time is that x. So the 4 and then the +1, that stays the same. So let's start going. So we do 4 to the -2 power plus 1. So make sure, right, when you're doing 4 to the -2 power, that is not doing 4 times -2, right? You're doing exponents. So plug it into your calculator. All of you have this on your computer. So 4 to the -2 power is 1/16, right? When you have negative exponents, that turns everything into a fraction. So you're actually doing 1/16 plus 1, right? So we're taking that number, adding 1 to it. Boom, 17/16, right? But it's kind of hard to figure out where that would be on the graph. So what we're going to do is go to our calculator and do 17 divided by 16. And if you want the decimal, just click your control button first. 1.0625. So 1.0625. Right, because the -2, all you're doing is changing that exponent. So let's do our next one. So now we're doing to the -1. So now we're doing 4 to the -1 power plus 1. So all we're doing is changing that exponent. So this, right, keep typing into your calculator. Boom. So 4 to the -1, that's 1/4. So we're doing 1/4 plus 1, which will get us 5/4, which is 1.25. So you can always plug all of this into your calculator if you want to know, right? Decimal, we would do 5 divided by 4 and then click the control before you hit enter so that you can get the decimal. Okay, now we're doing 4 to the 0 power plus 1. Right, so 4 to anything to the 0 power is just 1. So literally anytime you have something to the power of 0, where 0 is the exponent, it's just going to be 1. So now we're doing 1 plus 1, which is 2. Now we're doing 4 to the first power plus 1. So anything to the first power is just that number. So 4 to the first is just 4. We add 1 to it, now we get 5. And now we're doing 4 to the second power plus 1. So just taking the just taking the number that you have and making it the exponent, right? That's all we're doing for all of these, is just take the number that you have for x and make it your exponent. So 4 to the second power, that's doing 4 times 4, which is 16. Not 4 times 2, that would get you 8. You're doing 4 times itself, so 4 times 4. And then add the 1, which gets you 17. So now we're going to take all of these and put them onto our graph. So if we're going to turn each one into an ordered pair in order to put it on the graph. So our first one, we have -2 and then 1.6025. So our ordered pair would be -2 and then 1.0625. Our next one is -1 and then 1.25. Then we have 0, 2. Then we have 1, 5. And then we have 2, 17. So we're going to take each of these and then put them onto the graph and then connect the point. So our first one is you go to an x of -2 and then a y of 1.025, so something there. And then our next one was -1 and then 1.25, so pretty similar. So -1 and then 1.25, so pretty similar to that first one. Then it was 0, 2, so here's our next one. Then it was 1, 5 was our next one. Oh, that one didn't stay. 1, 5, there we go. And then our last one was 2, 17, so that's way up here. Okay, so then, right, you've got all of your points, right? So you can tell it's exponential because it kind of grows by a little bit and then all of a sudden it starts to skyrocket, right? So you connect your points and boom, there it is. And so the other thing to mention is, okay, so this +1 is kind of like your y-intercept almost. So this tells you that your line can't go below 1. Right, so if you're looking at my graph, you see it doesn't go below 1. Bye!